That's a huge first step, but it still doesn't solve the absolute biggest problem for any kind of digital cash.
Exactly. This is the whole ballgame, the double spending problem. If I have a digital coin, what's to stop me from sending it to you and then sending that exact same coin to someone else? With digital stuff, copying is easy. So how do you make sure a digital coin can only be spent once?
And that's the real challenge, isn't it? We need one single public ledger, a definitive history of every transaction in the right order that everyone agrees on. But, and this is the kicker, we have to do it without a boss. No bank, no central server, nobody in charge to say what's true.
Okay, and this is the heart of the entire paper. This is the absolutely elegant solution to creating that shared history without a central leader. It's a concept called proof of work.
The idea kicks off with something like a public timestamp server. Basically, you take a bunch of recent transactions, you create that unique digital fingerprint, the hash, and you broadcast it. That proves all those transactions existed at that moment. Then you take that hash and include it in the next one, creating a chain.
But, where do you publish this stuff? The paper jokes you can't just put it in a newspaper every day. So the network needs its own way of making this public and permanent. And that way turns out to be this really clever computational puzzle.
Think of proof of work like a lottery, but instead of buying tickets with money, you buy them with computing power. All the computers or nodes on the network are racing to solve a really hard math problem. The first one to find the answer gets to add the next block of transactions to the chain. So the majority vote isn't based on who you are, it's based on how much computing power you have. One CPU, one vote.
And this is what makes the whole thing so secure. If you wanted to go back and change an old transaction, you'd have to solve the puzzle for that block and for every single block that's been added on top of it since. And you'd have to do it all faster than the rest of the network, which is still racing ahead adding new blocks. It's basically impossible. And the security just stacks up incredibly fast. The paper actually does the math. It says if an attacker somehow controlled 10% of the network's power, once a transaction is buried under just 5 new blocks, their chance of ever being able to change it drops to less than 1/10%. The security just keeps growing exponentially.